Hello, this is Akshay Prasanna, 17PC0041, and along with KNHS on this 17PC2244, I intend to create a fully virtualized and para-virtualized guest using our Zen hypervisor, and this is for my review too. So for the project goals, the first one would be to install the Debian OS and installing the Zen project software next, and setting up an LVM storage for guests, setting up the Linux bridge for guest networking, configuring the grub to start the Zen project, creating a Debian para-virtualized guest and a Windows hardware virtualized guest. So to install the Debian OS, we first boot the Debian installer in the USB, insert the USB and configure the CD-ROM drive as your default boot device in your BIOS. This process changes from computer to computer, so it's better if you look at the YouTube video. And to begin the installation process, as soon as we're done, before that, we create the following partitions: SDA to boot for 200 MB, SDA2 for 15 GB, basically for space, so that we could store the Debian OS. And we need a swap area, which will be our third one, and for fourth one, it will be for LVM. And then we launch the Debian. Next step would be to install the Zen project software. The Debian Zen project packages consist primarily of a Zen project enabled Linux kernel, the hypervisor itself. All of this can be installed via an apt meta package called the Zen Linux system. A meta package is basically a way of installing a group of packages automatically. APT will also this will of course resolve all dependencies and bring in all the extra libraries we need. Install the Zen Linux system meta package using the following command: apt hyphen get space install space Zen hyphen system hyphen AMD64. So now shown is the software architecture of the Zen project Zen, and the guest VMs all sit on the hypervisor layer, as does the down zero, the control domain. The control domain is a virtual machine like the guest virtual machines, except that it has two basic functional differences. The control domain has the ability to talk to the hypervisor to instruct it to start and stop the guest VMs. The control domain is by default contains the device drivers needed to address the hardware. Setting up the LVM storage for guests, next step, where we first thing, LVM is a Linux logical volume manager. It's a technology that will allow Linux to manage block block devices in a more abstract manner. LVM introduces the concept of logical volume, effectively a virtualized block device composed of blocks written to one or more physical devices. Unlike proper disk partitions, these blocks do not need to be contiguous. Because of this abstraction, logical volumes can be created, deleted, resized, and even snapshotted without affecting the other logical volumes. LVM creates logical volumes within what is called a volume group, which is simply a set of logical volumes that share the same physical storage, known as physical volumes. The process of setting the LVM up can be summarized as allocating a physical volume, apt-get install LVM2, creating a volume group on top of this, pv-create/dev/sda4, then creating the logical volumes to store data, vg-create vg0/dev/sda4. Now LVM is set up and initialized so that we can later create logical volumes for our virtual machines. So next step would be to get the Linux bridge running for guest networking, and so we attach the virtual machines to the external network by this. This is done by creating a virtual switch within the DOM0. The switch will take packets from the virtual machines and forward them on the physical network so they can see the internet and the other machines on your network. The piece of software we use to do this is called as the Linux bridge, and its core components reside inside the Linux kernel. In this case, the bridge acts as a virtual switch, and the Debian kernel is complete with the Linux bridging module. So all we need to do is install the control utilities, which we can do it by the command apt-get install bridge-utils. So the next step would be to configure the grub and to start the Zen project. Because the hypervisor starts before the operating system, we need to change the way the system's boot process is present. The bootloader installed during the installation called grub is what tells your computer which operating system you need to use and how. So basically there'll be a priority difference, and hence we'll be switching the priority of our Debian OS to 1 and bringing up the Debian OS when the BIOS is loading. Debian configures grub for us using a number of automated scripts that handles upgrades, and these are stored in etc/grub.d and are configured via etc/default/grub. Change the order of the operating system so that the hypervisor is the default option, and use the following command for it. Then generate the /boot/grub/grub.cfg file by running the command below update-grub. Enable the Zen network bridge by editing /etc/zen/zend/ hyphen config.sxp and uncomment the line network script network bridge. Reboot and the default boot option will be our down zero running on top of the hypervisor. So the next step would be to create the para-virtualized guest, which will be our Debian again. The para-virtualized guests are notoriously different to install, being very difficult. Fortunately though, there are tools that help us prepare the images or snapshots of the operating systems to run inside guest domains. Debian contains a number of tools for creating the Zen project guests, and the easiest of which is known as Zen Tools. This software suite manages the downloading and installing of guest operating systems, including both Debian and RHEL based DOM views. In this project, we are going to use the Zen tools to prepare a Debian para-virtualized DOM view. When guests are para-virtualized, there is no BIOS or the bootloader resident within the guest file system, and for a long time, guests were provided with kernels external to the guest image. This, however, is bad for maintainability. Guests cannot upgrade their kernels without access to the DOM0, and it's not as flexible in terms of boot options as they must be passed on via the config file. So we configure the Zen tools and build our guest. Next would be the fully virtualized Windows hardware virtualized machine guest, where HVM guests are quite a bit different from the PV counterparts because they require emulation of hardware and they are more moving pieces than need to be configured. The main point worth mentioning is that the HVM requires the emulations of ATA and Ethernet and other devices, while virtualized CPU and memory access is performed in hardware to achieve good performance. Because of this, the default emulated devices are very slow, and we generally try to use PV drivers within the HVM documents. We will be installing a set of Windows PV drivers that greatly increase the performance once we have our Windows guests running. So by achieving all of this, the goals which have been asked for have been successfully achieved. We would have successfully deployed a para-virtualized and fully virtualized guest on our Zen hypervisor, which is deployed on top of the Debian OS. Thank you.